Welcome to today's deep dive. We are embarking on a very specific mission today.
A really fascinating one, actually.
Yeah, totally. Our goal is to uncover the factual clinical reality of the everyday sweet bell pepper.
Right.
And we have a pretty robust stack of sources sitting in front of us for this. I mean, we're looking at PubMed clinical trials, systematic reviews, meta-analyses, the whole 9 yards.
Exactly. We really wanted to dig into the hard data.
Right. So our goal for you today, the listener, is to kind of separate the proven biological health benefits of sweet bell peppers from the hyped up claims that actually belong to their spicy chili cousins.
Yeah, there is so much misinformation out there.
There really is. We are going to figure out exactly what this vegetable is actually doing inside your body.
And it is a surprisingly complex story. I mean, when we look at the clinical data, the bell pepper isn't just, a crunchy addition to a salad.
Right.
It's basically a masterclass in how a plant interacts with human biology. It completely alters our nutrient absorption and cellular defense.
Which is wild to think about. And to really appreciate that, I feel like we have to start with this fascinating case of botanical identity theft.
Ooh, I love that term for it, botanical identity theft.
Well, it's true, right? Usually when we think about how a wild plant defends itself from being eaten, we expect something aggressive, venom or thorns.
Absolutely.
If you bite into a wild chili pepper, the capsaicin immediately binds to the pain receptors in your mouth, and your brain receives a chemical signal that it is literally on fire. Nature is sending a very clear binary message, which is, back off and leave my seeds alone.
Yeah, it is pure chemical warfare. I mean, the plant invests an enormous amount of biological energy into producing capsaicin, specifically to cause physical distress in mammals.
Right, it's targeted.
Very targeted. And we understand that evolutionary dynamic perfectly. Mammals chew the seeds and destroy them, so the plant developed a weapon to keep us away.
Makes sense.
Meanwhile, birds who actually don't have those same pain receptors, they can eat the peppers and scatter the seeds whole.
Right. Which brings us to the everyday, completely non-threatening sweet bell pepper sitting in your crisper drawer right now.
Yeah, the innocent bell pepper.
Exactly.
Yep.
Suddenly that whole aggressive evolutionary rule book just gets thrown out the window. Because the bell pepper actually shares a family tree with those fiery jalapenos and habaneros.
They are direct botanical cousins.
But somewhere along the line, the bell pepper experienced this massive genetic glitch.
A very specific, highly consequential glitch. So the mutation occurred in a single gene, which is known to botanists as the PUN1 gene.
The PUN1 gene.
Right. And what that mutation did was completely shut down the plant's ability to produce capsaicin. The entire biochemical assembly line for spiciness just ground to a halt.
Wow.
So it literally lost its primary defense mechanism.
And this is where the identity theft comes in. Because if you look online, people are constantly hyping up bell peppers by claiming they'll, boost your metabolism, burn fat, help you live forever, simply because they're part of the pepper family.
Which is incredibly misleading.
They were totally stealing the spicy glory of their cousins. I mean, the sweet bell pepper has zero capsaicin in. It cannot give you a fiery capsaicin-induced metabolism boost.
No, it cannot.
But the clinical trials we pulled to this deep dive show something even more interesting, I think. When that genetic pivot happened, it resulted in a fruit packed with a completely unique, incredibly powerful payload of nutrients all its own.
Right, because without its chemical weapon, the plant had to pivot its entire survival strategy.
It had to do something.
Exactly. And the data reveals exactly what it replaced that capsaicin with. The plant essentially shifted from trying to punish predators to trying to bribe them.
Bribe them. I love that.
Yeah, it started producing massive amounts of vibrant, life-sustaining antioxidants so that we would want to eat it and spread its seeds.
So I want to get into the mechanics of those antioxidants, actually. Because I was looking through the notes on the chemical makeup of these peppers, and I realized I have fundamentally misunderstood the grocery store my entire life.
Oh, how so?
Well, when I see a display of green, yellow, orange, and red bell peppers, I always just assumed I was looking at completely different varieties of plants.
You are definitely not alone in that assumption. Most people think that. Oh, yeah. But for the most part, you are looking at the exact same fruit. What you are actually seeing in that produce aisle is just a physical timeline of ripeness.
Wait, so the green pepper is just like the teenager of the group. It just hasn't grown up yet.
It is simply unripe. That's it.
Mind blown.
Now, from a biological standpoint, being unripe still offers distinct advantages. The green pepper is actively photosynthesizing, so it boasts a really high concentration of chlorophyll.
Okay, that makes sense.
It also contains significant levels of a flavonoid called quercetin, which is a very potent antioxidant. But because it hasn't finished maturing on the vine, its overall vitamin profile is relatively low compared to what it is genetically programmed to become.
You know, it makes me think of a house under construction.
Oh, that's a good way to look at it.
Yeah, like you have the framing up, the foundation is poured, and it's definitely a structure, but it's not finished, it's empty inside. Then as it sits on the vine and matures into a red pepper, it turns into a fully furnished mansion.
I love that analogy. It's so accurate. The transition from green to red is a massive biochemical explosion.
An explosion.
Truly. As the chlorophyll breaks down, which by the way is why it loses that green color, the plant uses that energy to synthesize entirely new compounds at a staggering rate.
Wow.
The most dramatic shift we see in the clinical data is the production of vitamin C, or ascorbic acid. In a fully vine-ripened red pepper, the vitamin C shoots up to anywhere from 140 to 190 milligrams per 100 grams of the fruit.
That number just totally blew my mind when I read it.
Yeah.
Because, I mean, that is more than double the amount of vitamin C you would get in a standard orange.
Yes.
Just one red bell pepper provides nearly 188% of your daily required intake.
The plant becomes an absolute powerhouse of water-soluble antioxidants.
Yeah.
But the ripening process also unlocks an entirely different category of nutrients.
Right, the fat-soluble ones.
Exactly, the fat-soluble antioxidants. These belong to a family of plant pigments called carotenoids, and this is where the color coding really matters for you and your health goals.
Okay, let's unpack that.
So, red peppers exclusively synthesize two incredibly potent carotenoids called capsanthin and capsorubin. You absolutely cannot find those in the green ones.
So they don't even exist yet in the green phase.
Correct. Meanwhile, as the pepper passes through its yellow and orange phases, it produces high levels of different carotenoids, specifically lutein and zeaxanthin.
Okay, so if the mature red pepper has all these different types of nutrients living inside it simultaneously, you know, the water-soluble ones like vitamin C and the fat-soluble ones like capsanthin does, the way we prepare them in the kitchen dictate what our bodies actually absorb.
It dictates everything.
Everything.
In nutritional science, this is the concept of bioavailability. It fundamentally does not matter how many microscopic nutrients are packed inside the cellular walls of that vegetable. If your digestive tract cannot unlock them, extract them, and transport them into your bloodstream.
Right, you're just flushing them out otherwise.
Exactly. The cooking methods you choose act as the biological keys to these very different nutrient locks.
So we should probably break down the water-soluble rule first, because honestly, this was a tough pill for me to swallow as someone who just throws everything into a slow cooker.
The slow cooker.
Yeah, vitamin C is highly heat labile. It breaks down easily.
Ascorbic acid is incredibly fragile when exposed to sustained heat. Because it is water-soluble, it naturally wants to escape the plant matrix and leach into whatever liquid surrounds it.
Okay.
The clinical data is very, very clear here. Boiling a bell pepper is arguably the most destructive thing you can do to its vitamin C content. You will destroy and leach out anywhere from 27% to 69% of the ascorbic acid directly into the boiling water.
So you're basically just making a very weak, slightly peppery vitamin C tea that you then literally pour down the drain when you strain the vegetable.
Unfortunately, yes. Unless you are drinking the broth of that soup, those water-soluble nutrients are gone.
Wow.
If your goal is to harness the immune-boosting benefits of the pepper, to really saturate your blood plasma with ascorbate consuming it raw is absolutely the most effective delivery method.
Good to know.
If you prefer it warm, a very brief microwaving or a light steam is acceptable, as long as you keep it away from sustained heat and large volumes of water.
But then we flip the script completely for the fat-soluble rule. If you want those carotenoids we talked about, raw is actually the wrong approach.
It is the complete inverse mechanism.
This is so wild.
Yeah. Carotenoids, like the capsanthin giving that red pepper its vibrant color, are locked tightly within the plant's rigid cellular matrix. If you eat a red pepper completely raw, your body will manage to absorb a very small fraction of those carotenoids, but a huge portion will simply pass right through your digestive tract unabsorbed.
Just wasted.
Pretty much. Because they are fat-soluble, they require dietary lipid micelles, which are essentially tiny bubbles of fat, to act as transport vehicles across the intestinal wall.
Like little Ubers for the nutrients.
Exactly like little Ubers. Furthermore, they need heat to soften and break down the tough plant cell wall so they can escape and get into the Ubers in the first place.
I was reading through the clinical trials we pulled. And there was one human absorption study from 2004 that really illustrated this perfectly.
Oh, I know the one.
Yeah, the researchers gave participants red bell pepper puree. And when they co-ingested that puree with just 15 grams of olive oil, which is roughly, what, a single tablespoon?
About a tablespoon, yeah.
The bioavailability, the actual measurable amount of capsanthins that made it into their bloodstream, increased by over 300%.
It's massive. The addition of that dietary fat creates a multiplier effect. The heat of cooking softens the cellular architecture, and the olive oil provides the necessary transport vehicles for the gut to recognize and absorb the compounds.
Makes total sense.
Without the oil, those valuable fat-soluble antioxidants are largely wasted. We actually see this paradox perfectly illustrated by a very common pantry staple, which is paprika.
Oh, right, because paprika is literally just dried, ground up red bell peppers or very mild chili peppers.
Exactly. And when manufacturers dry the pepper at high sustained heat to create paprika powder, the fragile vitamin C is utterly destroyed. It oxidizes and completely disappears.
Just gone.
Gone. But that same high heat drying process super concentrates the resilient fat-soluble carotenoids. So a dash of paprika is a phenomenally dense source of capsanthin, but it contributes absolutely zero vitamin C to your diet.
So for you listening and standing in your kitchen right now, the practical takeaway here is that there is no single perfect way to eat a bell pepper.
No, there isn't.
You literally have to match your preparation method to the specific biological outcome you want. You slice a red pepper raw onto a salad to flood your immune system with vitamin C, and you gently stir-fry another pepper in a healthy fat, like olive oil, to unlock the carotenoids for your cellular defense.
Matching the preparation to the biological goal is the hallmark of informed nutrition.
Well, since we're talking about biological goals, let's look at the single most dramatic, scientifically proven impact that a raw bell pepper has when you combine it with other foods on your plate.
Oh, this is a great topic.
I'm talking about the iron multiplier effect.
Yes. This is one of the most robustly proven biochemical mechanisms in nutritional science, and it solves a major evolutionary problem for humans. We are actually quite inefficient at absorbing iron from plant sources.
Right, and we're talking about non-heme iron, right?
Yes, non-heme.
The kind found in lentils, beans, spinach. It's notoriously stubborn. Why does our body have such a hard time with it?
The issue really comes down to molecular shape and chemical bonds. The iron found in those healthy plants exists in an oxidized state called ferric iron, or Fe3+.
Okay.
Our intestinal receptors simply do not recognize or accept that chemical shape very easily. To compound the problem, those same healthy plants are packed with compounds called phytates, which are anti-nutrients.
Anti-nutrient.
Yeah, phytates actively bind to the ferric iron and hold it hostage, physically preventing us from absorbing it as it passes through the gut.
I noticed the sources mentioned an experiment addressing exactly this issue, specifically with iron-deficient women and lentils. How did the bell peppers factor into that?
That is the landmark 1989 crossover randomized controlled trial conducted by a researcher named Ballot. The setup was brilliant in its simplicity, really. They gave iron-deficient women a high-phytate lentil meal.
Right.
Under normal conditions, the human body absorbs a dismal 2.1% of the iron from that meal. The phytates win.
Wow, 2.1% is nothing.
It's nothing. But during the second phase of the trial, they had the women eat 100 grams of raw red bell pepper alongside the exact same portion of lentils.
Yeah, and the absorption of that plant-based iron skyrocketed to 7.1%. That is a 340% increase just from adding a side of raw vegetable. That is insane.
The biological mechanism behind that 340% increase is fascinating. The massive dose of ascorbic acid, the vitamin C from the raw pepper, enters your stomach acid and acts as a chemical reducing agent.
What does that mean exactly?
It literally donates an electron to the stubborn ferric iron, transforming it into ferrous iron, or Fe2+. That electron donation changes the physical shape of the ion molecule into the exact key needed to unlock your intestinal doors.
Oh, I see.
The phytates lose their chemical grip, and your body is suddenly forced to absorb the iron it was previously rejecting.
So it's like the vitamin C in the pepper is basically acting like a VIP bouncer at an exclusive club.
A bouncer. Okay, go on.
Yeah, like the plant-based iron is stuck outside in the line, the phytate security guards are holding it back, but the raw bell pepper drops in, grabs the iron by the collar, changes its jacket so it meets the dress code, and escorts it straight into the bloodstream.
That is a perfect analogy. The electron donation is exactly like changing the jacket to meet the dress code. It is a total game changer for human nutrition.
It really is.
If you are a premenopausal woman, a vegetarian, a vegan, or anyone who relies heavily on plant-based foods for your iron intake and struggles with low ferritin levels, this is highly actionable data. Simply adding half a raw red pepper to a bean chili or a lentil salad completely alters the mathematical absorption of that entire meal.
So we know exactly what the raw pepper is doing in the stomach. But what about the fat-soluble stuff? Once we've cooked a pepper in oil, unlock the carotenoids, and those lipid micelles transport them into our blood, where do they actually go? What are they doing to our cells?
The fat-soluble compounds, particularly the capsanthin and capsorubin we mentioned, travel directly to your liver and your adipose tissue, which is your fat storage.
Okay.
We have some very targeted clinical trials examining this interaction. One of the most compelling is a 2018 randomized controlled trial by Cochrane involving 100 healthy but overweight adults.
So I have the notes on this one right here. They were given an extracted supplement containing 9 milligrams of paprika xanthophylls every day for 12 weeks.
Exactly. Those paprika xanthophylls are the exact fat-soluble compounds we unlock when we cook red peppers in oil. Over those 12 weeks, through very precise CT scans, the researchers observed a significant reduction in visceral abdominal fat, which is the dangerous, metabolically active fat packed around your internal organs,
Wow.
as well as a reduction in subcutaneous fat under the skin, along with a drop in overall body mass index.
But how does a compound from a pepper actually shrink visceral fat? Like, what is the mechanism happening inside the body?
The current clinical understanding is that these specific carotenoids modulate lipid metabolism at the cellular level.
Okay, break that down for me.
When the capsanthin reaches the liver, it appears to activate certain nuclear receptors, specifically pathways related to fat oxidation. Essentially, the compound signals the body to upregulate the enzymes responsible for breaking down stored fat for energy, rather than continuing to store it.
That's incredible.
It is. Furthermore, a 2020 meta-analysis by Zhang, looking at 11 different trials, showed that these capsicum compounds produce a modest but statistically significant reduction in LDL, or bad cholesterol, likely through a similar mechanism of improved lipid clearance in the liver.
Okay, I have to play the skeptic here for a second, for you and the listener.
Please do.
These biological mechanisms are amazing, and obviously the results are proven. But we're talking about extracted paprika capsules in these clinical trials. We're talking about highly concentrated daily doses of xanthophylls.
Yes, we are.
How many actual physical cooked bell peppers would I need to eat to activate those fat oxidation pathways and shrink my waistline?
Grounding our expectations with this data is essential, so I'm glad you brought that up. The 9 milligrams of xanthophylls used in the Cochrane trial is a concentrated dose. You could potentially reach that level by heavily utilizing high-quality paprika spice in your daily cooking, but achieving it purely through eating fresh bell peppers would require a very consistent, high-volume dietary intake.
Right.
What these clinical trials prove is the underlying mechanism. They prove that these compounds actively interact with our human lipid metabolism. Eating a single bell pepper with dinner is not a pharmaceutical quick fix for high cholesterol or weight loss.
So it's not a prescription drug you take for a month to fix a problem.
Exactly the opposite. It is about the principle of lifelong dietary accumulation. It is about providing your biological systems with a constant, low-level stream of these metabolic regulators over years and decades. You are building an environment in your body that favors fat oxidation and lipid clearance over time.
That concept of, lifelong accumulation and building a protective environment makes perfect sense, especially when we look at the clinical data on what bell peppers do for eye health.
Oh, absolutely.
Because we mentioned earlier that as peppers mature through their yellow and orange phases, they produce high levels of lutein and zeaxanthin.
Yes. Those two specific carotenoids have a profound relationship with human vision. When you consume lutein and zeaxanthin with a healthy fat, your body actively transports them directly to the retina of your eye, specifically to a tiny area called the macula.
They just go straight there.
They literally accumulate there, forming a dense yellow pigment. This pigment acts as internal sunglasses.
Internal sunglasses.
Yeah. It physically filters out high-energy, damaging blue light and neutralizes the oxidative stress caused by photons bombarding your eye all day long.
That's amazing. And the sources reference the ARID-S2 trial regarding this, which, looking at the notes, is a massive landmark study on age-related macular degeneration.
The ARID-S2 trial is considered the gold standard in ophthalmology. In that study, researchers gave patients high-dose supplements of lutein and zeaxanthin 10 milligrams and 2 milligrams, respectively.
Okay.
The results showed a significant reduction in the progression of advanced macular degeneration, particularly in individuals who consumed diets historically low in those specific nutrients.
But again, looking at the math, to hit 10 milligrams of lutein purely from yellow bell peppers, you would have to eat an absurd amount every single day.
Right, you are not going to cure existing advanced macular degeneration solely by adding a yellow pepper to your stir fry. The clinical takeaway here is preventative architecture. The goal isn't to wait until your eyes are failing in your 70s to take a high-dose supplement. The goal is to consistently eat green, yellow, and orange peppers, properly cooked in oil throughout your entire life. You are actively building up that macular pigment year after year, so you have a robust baseline of physical defense against the aging process.
I love that phrase, preventative architecture. But because these protective benefits are so real, I mean, the iron multiplication is scientifically undeniable. The vitamin C levels are off the charts. The lipid metabolism mechanisms are proven. The internet does what it always did.
It takes things out of context.
Exactly. It takes a kernel of biological truth and turns it into a magical cure-all. You look online and you see viral claims that eating bell peppers will cure clinical depression or that they will guarantee a longer lifespan.
This is where we must apply rigorous scientific literacy. We have to draw a firm, unyielding line between solid clinical science involving human digestion and wishful preclinical thinking involving mice in a laboratory.
Let's tackle the mental health claims first because I see this everywhere. Bell peppers contain quercetin, which we established earlier is a great antioxidant.
Yeah.
And there are studies showing that if you extract quercetin and give it to mice, it modulates their serotonin levels and their HPA axis, effectively acting like a pharmaceutical antidepressant.
The crucial phrase in that research is "in mice." The preclinical data is genuinely fascinating. It demonstrates that under highly controlled laboratory conditions, these flavonoids can cross the blood-brain barrier and can reduce neuroinflammation in a rodent model. But there are absolutely zero human clinical trials proving that eating sweet bell peppers improves mood, cures human anxiety, or treats clinical depression.
Wow.
Taking a biochemical mechanism observed in a rodent's stress response and marketing it to vulnerable humans as a dietary mental health cure is intellectually dishonest.
It's super irresponsible. And we see that exact same misattribution happening with the longevity claims, too.
We do.
You read these massive longitudinal population studies, following tens of thousands of people for decades, showing that consuming spicy foods reduces all-cause mortality by 13 to 14%. And people read a headline that says peppers help you live longer, and they automatically assume that includes the sweet bell peppers in their salad.
Which brings our deep dive, full circle really, right back to the genetic glitch we discussed in the very beginning.
Oh, right.
Those massive longevity studies are specifically tracking the dietary consumption of capsaicin. Capsaicin triggers specific thermogenic and gut microbiome pathways that heavily correlate with reduced mortality.
But the bell pepper experienced the PUN1 gene mutation.
Yeah.
It literally evolved not to produce capsaicin. So it doesn't have the chemical key to fit that specific longevity lock.
Exactly. It lacks the fundamental compound driving those exact mortality statistics. Any longevity benefit you receive from a bell pepper comes from the simple fact that it is a nutrient-dense, fiber-rich, low-calorie vegetable. Populations that consume high volumes of diverse vegetables tend to live longer, healthier lives. But there is no magical, sweet, pepper-specific pathway to immortality.
Well, this has been incredibly revealing. Let's bring this all together for you listening at home. What are the actionable daily takeaways from this deep dive?
First, pay close attention to the color timeline. If your primary biological goal is maximizing your vitamin C intake, you must choose the fully mature red or yellow peppers. They are the fully furnished mansions of the antioxidant world.
Right. Second, if you want to utilize that massive dose of vitamin C to multiply your iron absorption, say you're eating a high phytate lentil stew or a spinach salad, you must eat the pepper raw. Do not boil it and destroy the ascorbic acid. Let it act as the chemical bouncer, changing the shape of that plant-peaked iron so your body can actually absorb it.
And finally, if your goal is building preventative architecture for your eyes with lutein, or engaging your liver's lipid metabolism pathways with capsanthin, you must liberate the fat-soluble carotenoids. Lightly sauté those mature peppers in a healthy fat, like olive oil or avocado oil, to unlock them from the plant's rigid cellular matrix.
It is genuinely amazing to realize that all of this biological complexity, all of this nutritional wealth exists purely because of a single missing gene,
It really is.
which leaves us with a really fascinating concept to ponder. If the bell pepper, simply by experiencing a random genetic mutation, completely shifted its evolutionary survival strategy from, burn the mammalian predator away with pain, to bribe the predator to carry my seeds by offering them vibrant, life-sustaining antioxidants, what other hidden genetic glitches in our everyday foods might be secretly offering us entirely different health paradigms, just waiting for the clinical trials to discover them?
It is a profound reminder that nature is constantly running biochemical experiments, and sometimes the mutations that initially appear to be a loss of defense turn out to be an extraordinary nutritional gift for humanity.
So the next time you are standing in the produce aisle looking at that display of red peppers, remember you aren't just looking at a simple salad ingredient. You are looking at a masterpiece of evolutionary bribery.